Next, we're going to look at second order uncertainty. So first order uncertainty is to try to simulate the 5-day change, but when we did the estimation of the probability distribution, we used just this one set of data, which itself is a sample. So if we took a different set of input data, we may get different parameters for the best fit. We have Laplace with two parameters, right? So these parameter estimates are based on a sample. So how do we know that these estimates are accurate or not something different? So that's what is called parameter uncertainty. The mu and sigma of the Laplace distribution are estimates from this observed data. Now the estimates take a different 3-year data set. We may get different parameters, right? We may even get a different probability distribution altogether, and that would be model uncertainty. But right now, let's focus on parameter uncertainty. So given a distribution, the parameters could be different if you have a different set of data. So to mitigate that, we can use bootstrap option in the fit distribution, and we can generate, bootstrapping means, you have the data, you go and sample the data again and again and again, and then compute your mean from those observations. So we can generate 1000 estimates for mu and sigma, and then use these 1000 estimates of mu and sigma as the parameters, and then run the simulation. So that's what we're going to do now, parameter uncertainty and bootstrapping. So select a cell in the data range, go fit, okay, fit. Now make sure that the data starts from D6, then go to Bootstrap and make sure that you're going to run Bootstrap. So we're going to sample 1000 times. Okay, click OK. Okay, so now we have the fit. Okay, now you go to that button. Okay, so we have parameters. Okay, so now you see the mean and sigma values, 95% lower limit, 95% upper limit, confidence width for all the 1000 mu's that we generated, and the corresponding sigma. So select mu, and then here display data grid. Okay, so now we have 1000 mu's that we have selected. So highlight that, copy, and paste here. So now we have Laplace mu. Okay, so let's make it, select symbol font, and you get Laplace mu, and then we will do Laplace sigma next. So highlight sigma and repeat. So go to 1 and go all the way down. All the way down, so you have 1000. So copy that and paste that. Okay, so now we have 1000 estimates of mu and sigma. So we can do bootstrap value. So we have Laplace, risk Laplace, okay, mean and standard deviation. So that gives us our estimates, okay, based on each sampled mu. Okay. Okay. And then we will set up the percentile. Okay, first percentile. Okay. Okay. Risk percentile. See, there are two percentiles. There is risk percentile and risk theoretical. So that is Theo percentile. And Attrix suggests that we use Theo percentile for input values and percentile for output values. Okay, since this is kind of an input value because we are simulating the from the Laplace, so let's use Theo percentile of that value, okay, which we're going to simulate, all right, and the first percentile. Okay, so that is our first percentile estimate of the 5-day return. All right, so now we can run the simulation. So each bootstrap value will be simulated, and then we will have the first percentile of those 10,000 values for each bootstrap value will be displayed here in column X. When you have lots of input cells, we have 1,000 of them here in the bootstrap value. So it not only takes time to get initialized, it takes time to run the simulations as well. So it took almost more than 2.5 minutes to get the simulation completed. Okay, so now we have simulation is done. So we have the first percentile returns with bootstrap. Okay, so each bootstrap value, remember there are 10,000 repetitions, and here you can look at each one of them in the output histogram, and these are the percentiles. So let's close this and let's set up the second order uncertainty. Here we're going to look at let's copy that here. So now this is best fit Laplace. Okay, so bootstrap, let's call this bootstrap. Okay, and we'll do average first percentile. Okay, we'll call it mean first percentile. Okay, and then fifth percentile of the bootstrapped first percentile. So that's fifth percentile, and then the first percentile. Okay, so here it'll be average of the first percentiles we have from the bootstrap. Okay, so that's your average. Okay, so let's say average first percentile. I hope it fits better now. I don't know. All right, so we have the fifth percentile. So we can now use regular Excel percentile. So percentile.exe of these x values, I mean the first percentile values, comma 0.05. So that gives us the fifth percentile. So let's look at the first percentile. So I went into edit mode, copied, and then we copy here and make that to first percentile. Okay. Now value after 5 days for first percentile is now 911, and so at first percentile the value at risk in 5 days is $89, and this is more robust because of the way we did the analysis. We did a bootstrap estimation of mean of the parameters for Laplace. Okay, now let's go back here. So we did parameter uncertainty. We handled parameter uncertainty. All right, so the model uncertainty, again, we have to repeat this for different models. So we have best fit, second best fit, and another one. And if you have like 4 or 5 different probability distribution estimates that you want to try, so you repeat this process for different models and look at VAR for different models, and that will give you a little more confidence in terms of the total value that will be at risk in 5 days.